All right, let's take a look at this circuit. We are asked to figure out what is the node voltage at nodes marked 1, 2, and 3. So V1 is the node voltage at node 1, V2 is the node voltage at node 2, and V3 is the node voltage at node 3. We're also asked to figure out that middle current Ix. Okay, so here let's start out by first placing a source ground reference node. So since the reference node is not on either side of the voltage source, that is what makes this 6-volt source a super node. Be very careful in this particular problem because the polarity of the 6-volt has plus towards the V2 side and minus towards the V1 side. Okay. Before we start on anything, let's first write down the directions of some currents. There is a zero point 0.5 ohm resistor right here, so we can arbitrarily draw the currents. In my example here, I am going to arbitrarily choose a downward direction for that current. So that I'll call that I1. Similarly, for this 0.5 ohm resistor, I'm going to choose an arbitrary current direction moving from V2 towards V3, and I'll call that I2. All right, so I have my currents all marked. Now, the first thing I want to do is that at the super node, I want to basically write down the expression directly because V2 right here is on the plus side, V1 is on the minus side, and the overall voltage polarity is 6. So this basically means V2 is 6 volts higher than V1. In other words, V2 minus V1 is 6 volt. Okay. Next, I want to do a Kirchhoff's current law at this node right here, that node. So at that node, current coming in is equal to I2, that is I2 coming in. 4 amp is coming in, so I2 and 4 amp are the total sum of the currents coming in, I2 plus 4. All the current coming out of that node is 2 amps, so I2 plus 4 equals 2. Simplifying this, we can get I2 to be equal to 2 minus 4, so in other words, negative 2 amps. So I2 equals negative 2 amps, right? So we don't need to panic, right? So the current is negative 2, which basically means that this arbitrary current direction I had chosen is actually flipped, right? So basically means that V3 is at a higher potential than V2, and that current actually flows in this direction, but we don't need to make any changes to anything right now, okay? So we basically write down V2 is we assume V2 was at a higher potential and we drew the current in this direction, and then we find out that the current is negative 2. We'll leave it as that and proceed accordingly. So let's move on. So next thing we're going to do is a supernode. So essentially, a supernode is a giant node. Kirchhoff's current law holds true at a supernode just like it holds true at a regular node. So the total current coming into the supernode, let's observe this. What are the different currents coming into the supernode? I see only 2 amps coming into the V1 side of that supernode. So the total current coming into this supernode is 2 amps. The total current coming out of that supernode, let's see, I1 is coming out of the V1 part of the supernode. Ix and I2 are coming out of the V2 part of the supernode. So the total current going into the supernode was 2 amps. The total current coming out of that supernode is I1, Ix, and I2. So using Kirchhoff's current law at the supernode, we can write 2 equals I1 plus Ix plus I2. Now, using Ohm's law, let's replace values of I1 and Ix. We already know I2 is negative 2 amps that we calculated right here. So I1 starts at V1, goes towards the reference node, which is at 0 through the 0.5 ohm resistor. So we want to write I1 as V1 minus 0 divided by 0.5. Ix similarly goes from V2 towards ground through 0.5. So we write that as V2 minus 0 divided by 0.5. So 2 equals V1 minus 0 divided by 0.5, so that's I1, plus V2 minus 0 divided by 0.5, that's Ix, and I2 we already calculated as negative 2. So we'll leave it as that. Let's move minus 2 on this side, so 2 minus 2 when this moves this side becomes plus 2, so 4 equals V1 divided by half plus V2 divided by half. Right? So if I take 1/2 common out of these two expressions and move it on this side, I basically get V1 plus V2 equals 4 times 0.5, which is equal to 2. So here's 2 equals V1 plus V2. So in this overall expression right now, I have one expression right here, one equation 1, and my second equation is right here. So I have two equations, And these equations are fairly simple. One of them says V1 plus V2 equals 2. The other one says negative V1 plus V2 equals 6. Now I can use MATLAB, I can use my calculator, or these are two very simple expressions. So even if I use algebra itself, I see V2 plus V1 equals 2, V2 minus V1 equals 6. So if I add this equation and this equation, I basically get 2V2 equals 8. 2V2 equals 8. In other words, V2 equals 4 volts. So I can solve V2 equals 4 volts without using MATLAB calculator or anything. So V2 is 4 volts. So that means 4 minus V1 equals 6. In other words, V1 is equal to negative 2 volts. Another way to do that is V2 is 4. That's 2. So V1 is 2 minus 4. So V1 is equal to negative 2 volts. Right? So that's what we have so far. All right, now let's see. So we figured out the node voltage for V1 here. We figured out the node voltage for V2 here. Let's figure out V3 first. I mean, we have enough information to calculate Ix, but let's calculate V3 first. Now V3, right? So we wrote, so this I2 right here, which we calculated before right here, I2 basically has current direction moving this way. So V2 minus V3 divided by 0.5 is equal to I2. So let's write that down. V2 minus V3 divided by 0.5 equals I2. Now I2 is negative 2, so let's substitute that. Right? Now from here, if I move 0.5 this way, so 0.5 times 2 is 1, so 0.5 times negative 2 is negative 1, so V2 minus V3 is negative 1. We calculated V2 to be 4 volts already, so 4 minus V3 equals negative 1. In other words, V3 is equal to 5 volts. Okay, so we figured out the 3 node voltages that we've asked for. Now, Ix is another thing that we were asked to figure out. Ix goes from V2 towards ground through the 0.5. So writing that, Ix equals V2 to ground divided by 0.5. So we can simplify that as simply that. So V2 is given as V2 is given as 4 volts. So 4 divided by 0.5 is equal to 8 amps. So that is the overall solution to this particular problem, right? So the key thing to note is that as long as you're thinking about and applying node voltage method, a supernode is essentially nothing more complicated. In fact, it simplifies the solution because a supernode immediately gives you an expression like this. One side of the voltage source minus another side of the voltage source is equal to the magnitude of the voltage source. And the key thing to remember is that the Kirchhoff's current law works on a supernode just like it does on a regular node.